Thank you for joining us. Tony Mormino here with the Engineers HVAC podcast. And we're so glad you're joining us. This is a special live version streaming on LinkedIn, Facebook, YouTube, and about 6 other channels that I'm not quite sure where we're going, but we're going out there today. And thank you so much for being here. So our mission here is to empower and educate the HVAC community. And this channel is brought to you by two rep firms, Hobbs and Associates and Insight Partners. And thank you so much. I'm Tony Mormino. I'm your host. So I have a surprise guest here today. We scheduled this event. We scheduled this event with HVAC expert Don Gillis, who canceled. So Don is going to come tomorrow. I shouldn't say canceled. He moved it. He moved his VIP position here to tomorrow at 10. So tomorrow at 10, Don Gillis will be here. So lucky for me, I was on a call earlier with Clifton Beck here. And I said, what are you doing at 4:00? And he said, why you ask? Something like that. And now I got two experts. So today we're going to have Clifton Beck here, HVAC, refrigerant expert and training expert. We'll talk a little bit about what he does. And we're going to go over the A2L transition, R410A transition to A2L refrigerants. We're going to talk about the important dates. We're going to talk about the A2L-ness, the A2L classification of the refrigerant, what that actually means. We'll delve in a little bit about the transportation and then training on this as well. If you have questions, please put them in the chat. We love to get questions and we'll kind of play off of that. And this is a PDH style presentation. So, hey, Hiban, joining from Atlanta. Hope you said your name right. Thank you for joining us. This is a PDH presentation. So my email is in the bottom there. You can email me for a PDH certificate after this. So we already got some questions coming in. So that's great. So Clifton, so Clifton, why don't you introduce yourself? Tell us about ESCO.
Sure.
And then we'll get into this thing.
Yeah, so I'm Clifton Beck. I'm the manager of digital media at the ESCO Institute, which is part of the ESCO group. So we are a standards and certification organization. Been around the industry a long time, and we primarily work with our schools, our educators around the country. And what we are experiencing right now is a lot of need for education on the transition, the refrigerant transition that we're going through, and just understanding what that looks like. So we do a lot of training, we do a lot of certification, and I'm very excited to be hanging out here with you, Tony. We just got to meet at AHR for the first time. We've known each other virtually, but in presence, it's always a different scenario. So I'm very excited to be here. I'm a technician nerd at heart, really. So I spent about 25 years out in the field, a lot of refrigeration. So I actually went through the CFC phase out and the HCFC phase out, and now just in the third refrigerant transition and trying to help technicians understand what does that look like. It's a lot.
That's great. And I'm glad you're here with the hands-on technical experience. I've been more on the sales and engineering side, so it's always great to have folks who've been in the field. It's a good compliment. So what I thought we would do is talk a little bit about, like, for those who don't know, let's talk about what's actually happening, right? So I call it an R410A phase down. I've called it a phase out, which is probably not accurate. A transition to A2L refrigerants. And what's driving this whole thing, when you were talking about previous transitions, when I started in 97, we were going from CFCs to HCFCs, okay? And then HCFCs to HFCs. So it was like, that was all about the chlorine. It was all about the ozone layer. So we had this hole in the ozone, the chlorine was affecting it, yada, yada, yada. We were reducing the chlorine, the refrigerant. Now it's all about GWP,
global warming,
right? Global warming potential. So, it's really not a R410A phase out. No. It's not just a 410A thing. It's a high, quote unquote, high GWP refrigerant phase out. So anything over 700. That's right. 700 GWP is getting phased down. So why don't you mind hitting the dates, the important milestones in terms of manufacture, in terms of equipment? Like a lot of our viewers are mechanical engineers and mechanical contractors. They work on a lot of commercial jobs. When do they need to order equipment by? Like, what's the last shipment they can get for 410A equipment? Why don't we start with that?
Sure, that's the hot one, especially when we start looking at the residential. So residential is set for January 1st of 2025. So that's no newly manufactured equipment. But we're going to have a sell-through date, and that recently got amended through the EPA. So that gives us an additional 12-month of sell-through for our components. But for manufacturing, we're in the last year of manufacturing of R410A equipment in the residential. Now we can pull out the guidelines for the technology transition rule, and we can look at those. I can actually pull them up here in a second if we want to look at any other pieces of equipment. But that's the ones that we've been focusing on the most recently because it's so imminent. I mean, it is coming. We're in the last phase of new R410A equipment, and that's kind of an intriguing but yet kind of scary topic at the same time.
Mm-hmm. Yeah. So commercial chillers, HVAC equipment, not including VRF, the last ship date from the factory, 1/1/25, right? So if it's VRF, you get an extra year for some reason. So that's 1/1/26. So, as equipment reps, which is what we are encouraging engineers to, it's funny. Like my experience says, don't order something new right now. Wait, get it out in the field, get it tested, check it out first. But you know what I mean? There's no time. Like there's no time to do that. So you're really stuck. So if you're specifying a job right now, if you're an engineer, you probably want to start getting selections for the replacement refrigerants, which we'll talk about in a minute, which are R32 and 454B, right? If you're going to get a 410A machine, you got to get it soon. You do get another year to install it. So if it ships in December, you get another year to install that. But if you're specifying a job, let's say, and it's not going to ship till next year, you definitely want to start specifying that on the new refrigerants. So so there's the two components to the transition, right? There's the equipment deadlines. I can't ship this past a certain date. And then there's actually the manufacturing of the refrigerant deadlines, right? So you want to talk, not deadlines, but reductions. And I think we were at 10% last year. Now we went down another 30%. Is that accurate?
Yeah, so if we look at what has happened primarily with the Kigali Amendment, so we have two things going on that's affecting the HFC phase down. So you have the Kigali Amendment to the Montreal Protocol, and then we also have the AIM Act. So we initiated this entire phase down a long time ago, actually. So we're approaching a decade of discussing what this was going to look like. So if we look at that phase down, that schedule, we had a 10% reduction in January 22. Now remember, that is the manufacturing of new refrigerants based on GWP. So if a manufacturer of refrigerants has refrigerants that have different GWPs, they can produce more of the less amount of GWP refrigerant. So it's all based on total global warming. So Jason Objute from our team always talks about, like, we got this great big piggy bank of GWP. So it's not really pounds of refrigerant, it's GWPs of refrigerant. So if I have a refrigerant that has a GWP of 1,000 and I have a refrigerant that has a GWP of 1, I can sell 1 pound of the 1,000 GWP and 1,000 pounds of the 1 GWP. So the manufacturers are having this balancing act of how do they collectively look at all the refrigerant demands for new equipment and replacement refrigerant and decide what is the best utilization of their GWPs. So that was January 1st of 2022. Anybody see price of R410A and other HFCs go up in 2022? Right? Well, January 1st of 2024, we added an additional 30% to that slide. So we are actually at 40% from our original baseline of refrigerant manufacturing than what we were in 2021. So it's a big slide. 24 is going to be a interesting and challenging year for the entire industry.
Yeah, because, we're still making our R410A equipment.
Absolutely.
As much as we ever have, really. Maybe a little bit less because people are switching over.
Starting
But
to see some transitions, yes.
yeah. So that's I think they staggered. In my opinion, no one came to ask Tony like my opinion on when they should lower the manufacturing, but I think they should have overlapped it a little bit better. It certainly makes it hard, and it's funny. This no matter where I present this, either at ASHRAE or like internally or live, we always get these questions. I'm like, look, we're reacting to this stuff. We don't really get a big seat at the table when it comes to these policies and the transitions. It's all made at higher levels than us, and we do our best to react to them. And they're kind of a pain in the butt, but we get through them the best we can. And I think we've got a good history of doing that. So okay, so we talked about the dates. We talked about R410A. So the restriction on the refrigerant is a GWP of 700, a global warming potential of of 700. That's the limit. So if you're a manufacturer of HVAC equipment and you use 410A, which is what a lot of people use, you have to replace that with a refrigerant that has a GWP less than 700, among other factors, but that's what's driving this change. So the two refrigerants are, why don't you fill us in on the two refrigerants that most people are going with?
Absolutely. So we're pretty well split in the industry. We see a variety of R32, and we also see a variety of R454B. And I always like to help people understand what that looks like, especially when we start talking about, in a comparison on our PT chart, what are we going to see? Well, if we think about R410A, right?
Hey, Clifton.
Yes.
Can you pause for a second? I think your sound is a little why don't you do this? Refresh your browser real quick and come back in. We lost you're out of sync a little bit. Go ahead and do that. It'll be fine. I think it'll work fine. Sorry about that, everybody. When you're live, you never know what's going to happen. Okay, I got you back. So
there we go.
It's a good testament to show that we are actually live.
See, yeah, absolutely.
Anybody thought we were faking? We don't fake around here, man. We do it for real.
Impromptu. We decided this an hour ago?
That's right.
So if we talk about R410A, and if you're not already familiar with R410A, it's a composition of two different refrigerants, two different chemicals. So it's a 50% blend of R32 and a 50% blend of R125. That makes up R410A. We actually had the chance to go with R32 back in the late 90s when we were proposing the transitions into R410A, but building codes were never ready for the flammability factor of it. So we blended in 125, which is a flame deterrent, and we came up with R410A. So going forward, we're going to have two primary refrigerants. We have that base refrigerant, that 50% base of R32. So it's going to be a single constituent refrigerant, no blend. And then we're going to blend R32 with another refrigerant called 1234YF. If anyone's not familiar with that, we use it a lot in the automotive industry. It's a very popular HFO refrigerant. So we're going to have R32 on its own with no glide, and we're going to have R454B, which is 32 plus 1234YF, that has a very, very small amount of glide. And that will be our two refrigerants going forward. I always like to make sure people are aware that R410A actually had glide to it. It was two different refrigerants, but it was so close, we never truly took it into effect when we're looking at things like subcooling and superheat. Right. So that will be the two primary refrigerants that we will see in residential, like commercial.
And could you touch on what glide is for those who don't know? Because I think, like from an engineering standpoint, here's one thing I'll say too. Like I've been in the industry for a long time, right? If you're an engineer, there's two viable refrigerants that Clifton's doing the next job talking about: R32 and R454B. If you got someone coming to you and pushing one or the other and selling against the other one, that's because they only got one. That's the Tony Mormino. My experience of that is what's happening there. Both of these refrigerants are very safe, very reliable. So someone might say, "Oh, that has glide." We don't. Talk about glide and what that really means. Because 410A had glide too. Minor
very minor. I always like to use water. It's the simplest process that we have that we can understand what glide looks like. So I'll use this in a classroom. Say if I have a flask of water and it's in atmospheric pressure, no cap on it, and if I raise that temperature and I raise it to around 212 degrees, what am I going to do? I'm going to change state from a liquid into a vapor, right around 212, right? Now, what happens if I come backwards and my vapor comes back down to that 212? I get below that, I'm going to be liquid, right?
Mm-hmm.
So we're just talking about gas laws. Well, it's very specific for superheat. If I go above 212, I'm going to be a superheated vapor. If I go below 212, I'm going to be a subcooled liquid. Well, what happens if I mix two different liquids together and they have slightly different boiling points? That means in between those two boiling points, I have a little piece of space called glide, where I'm in between states as a total. So if I take two different refrigerants and I go, okay, I got a boiling point here and I got a boiling point here. That means in between, I'm not really going to calculate much with that. But if I'm above here, I'm going to be in my vapor state, so I can be superheat above there. And if I'm below here, I'm going to be liquid, and I'll be able to utilize that for subcooling. So we have a little bit of dead band in between where we haven't changed state completely. So we'll see a very small amount of glide in 454, but we also seen a very small amount of glide in R410A, and it wasn't significant enough to be a major concern.
Right. And why that's important is if you have a refrigerant that has a large glide
Mm.
and you get a leak, you can't just top it off. There's rules about it. You probably know about more about that than I do. So if you have a refrigerant that has a huge glide and there's a leak, you have to take it all out because you don't know what the ratio is. Because one
Right.
refrigerant may of the two may have leaked more than the
Escape.
other one, depending on where it is. So
Yeah,
yeah.
exactly. I always talk about like, all right, say we have a tube in maybe an evaporator, and I have two liquids passing through that tube, two different chemicals. And if I happen to be in that little bitty space of glide, I could have primarily a blended liquid on the bottom, but on the top of that tube, I could actually have vapor from one of those chemicals and not the other.
Mhm.
So if I had a hole on the top of that tube for a long period of time, I could actually potentially lose one of those chemicals. And so if I add refrigerant on top of it, I'm now a chemist with a whole new chemical that is not classified and not registered, and I don't know how to calculate superheat and subcool with it. So yeah,
Yep.
I know I'm going on my
Good to know. Good to know.
tangent.
I know it. So we were talking about A2Ls, and I went down this rabbit hole of the glide, but I forgot where we were going with that. Oh, we were talking about the two viable replacements, right?
Yes.
So R32 and 454B. What about from like a pressure standpoint, temperature standpoint compared to 410A? You tell us what your experience is with
All
that.
very, very similar. We're only going to be a few PSI off at different temperatures. And I need to do that. I've got a slide that I put together for 32 and 410, but I don't have one for 454B yet. I need to do a comparison of all three of them so that you can see, but they're very, very similar. We're not talking about drastic differences. Like if we go
Hmm.
back and we talk about like that HCFC phase out where we were going from 22 to 410, there were big pressure differences, right? Sometimes we had to even change our gauges because we weren't reading high enough pressures. Well,
Hmm.
when we make this transition, our actual PT charts are not anywhere significantly different as we were in the past. We still need to get comfortable using our PT charts once again, or always like we should. And there will be software updates for digital gauges that are already A2L compatible. And so we're just going to do firmware updates to modify our PT charts.
Yeah. So if you're a manufacturer and you're a tech, it makes things a lot easier from the last transition. So
Oh, yeah.
you look for that refrigerant, and manufacturers have to make the decision which refrigerant to go with, and they look at probably many factors of the refrigerant, where it's made, who makes it, the
Yes.
cost, the pressures, the temperatures, and then they pick the one that best matches their, economically it's best for them. So what different manufacturers are announcing what they go with. Some manufacturers are going with R32, some are 454B, but they're both under 700, so they're both okay.
Yeah.
And they both work great, and they've both been around a while. There's nothing new, and I always like, we're going to get into the A2L classification, which I think, at least what I've seen, that's the most different thing about this transition is it's a considered lightly low flammability, I think is a technical term. But and I always say, well, you got an A2L in your car. If you've got a newer car over the last 5 or 10 years, you've probably got, is it 1234 YF? Is that the
Yeah.
refrigerant in automobiles?
Yeah, so we actually introduced that very first vehicle was 2012 with a Cadillac CDS, and then
Hmm.
we started migrating into light duty trucks in 2015, and we are now going to be so you got to remember, we're not the only industry going through these transitions. Every industry that uses chemicals and regulated substances are going through these same transitions. So automotive is in their own phase out of 1234
Hmm.
YF to go to 1230 or from 134A to go into 1234 YF in this same one. So they're scheduled for model year 2025. So think about that. We think about we're the ones struggling to make this transition. What if you're an automotive technician and your model year is 2025? Tony, when does the model year 2025 vehicles come out? Sometime in late 2024. So
Right.
they've
Right.
already had to make that transition. So yes, we
Yeah.
will see 1234 YF in all of our new motor vehicles.
Got it. So we do have a question. Matthew Trotter is asking, when will the final rule be finalized?
No, that's a great one. So now it's a good question because this is kind of a two-part loaded scenario. Are we talking about the final rule for the technology transition rule? Because that one will be in September. So that's when we finalize for sure any changes that we're going to be making off from the technology transition. But there are still things in there like the AIM subsection H of the AIM Act, which is another rule. So we're going to see a variety of things happening this year, but the final rule for technology transition rule that just came out from EPA a few weeks ago, and I believe September 18th, but I could be off on that date, but in that ballpark.
All right. So I'm been giving this presentation for a year now, and Don told me that yesterday, and you told me this today. So the technical transition rule is different from the NOPR before it was approved, or I don't know what the technical term is, but was the dates of the manufacturing. You can't manufacture equipment after this date, and it was the phase down of extra refrigerant. But this is something different. This is a different part of the AIM Act, the technical transition rule. Is that what it's called? Am I
Technology
saying that right?
transition rule, yeah.
Technology. Okay.
And so Tony, I will share with you. I've actually got that final rule if we need to share that or if you want to see any of that, because it's
Sure.
broken down between two different things. And so this is where people will sometimes not understand exactly what that looks like because it is going to be different between our products. And I'll show you.
Yeah.
Right,
Take your
let me
time.
share this one up. Yeah, so this is one. So with the technology transition rule, what we're doing is we're setting all of the dates, but we're also setting, in addition, some refrigerants that are in those. So when we look at the technology transition rule itself, let me get over here where I can scroll. This is our technology transition rule, the final of the technology transition rule, which we are already into. And this is what we're breaking down by these refrigerants. So just depending on what that equipment is, every sector is getting some kind of a change. And it's not just 700. Now, we recognize
Hmm.
700 for stationary residential, like commercial heat pumps, but we also have to think about things like vending machines. We're going to see a 150 GWP limit on that. And so we have a variety of different applications for products. Yes, we are going to see the 700 for our chillers and standalones and data centers, but we're also going to see industrial process refrigeration, some of those going down as low as 150. Retail food refrigeration, 150 by January of 2025.
Mm.
So all of our commercial refrigeration folks out here, you're going to see not just the transitions with our 32 and 454, you're going to see all sorts of new refrigerants. Like that 454, there's actually three of them. There's
Mm.
454A, B, and C for different applications for different medium and high and low temperature or pressure pieces of equipment. And they're just different blends of 32 and 454. So it depends on whether it is, so you notice on the technology transition rule, you've got products,
Hmm.
and then you've also got down further another little disclaimer for systems. All right. So
Mm.
it depends on how it was designed. But most of it stays very consistent, especially in our side of the industry when we're talking about residential, light commercial, and our industrial. When we're talking about HVAC systems in general, we're going to be in that 700 GWP by January 1st of 2025.
Nice. So here's a question I've gotten every time I show this part of the rule. Hey Tony, if any machines can go down to 150, why are we at 700? And I say, I'm not sure, but I think it's because they can. We don't
That's
have the
very
ability to do that with a 50-ton packaged unit that I'm aware of.
well, and so what we find in a lot of this is the capability of refrigerants. So I've spent
Mhm.
a lot of time talking to our different chemical manufacturers on what abilities and inabilities we have with the refrigerants. And remember, so we're talking about the design pressure and we're talking about the design temperature that our refrigerants are going to be going into a system and what oils they're going to be running, what types of compressors. So what we find is we don't have a lot of solutions. We're kind of limited with what we can work on. And especially in the residential and light commercial, now we have the whole flammability concern, right? Because
Mhm.
our lowest GWP refrigerants typically have the highest flammability, except for things like CO2, which has a high pressure. So as we start, as a rule of thumb, as we
Mhm.
approach lower GWP on our refrigerant, we're gaining flammability. And so it's a combination of, well, how much refrigerant can I put into a system? So some of these smaller systems are actually going to A3 refrigerants. That's where that 150 comes into play. We're going to see a lot of A3 highly flammable refrigerants going into some of those smaller pieces of equipment.
Got it. Okay, so that's good. And that's a good segue in the A2L. We'll talk about that in a second. We got another question from Rachel Stalker. Yeah, Courtney, just send those through the private chat. That's perfect. So Courtney Sanders is working to keeping the ship going here. You're doing a great job. So Rachel Stalker, I hope I'm saying that right, is R134A on the same phase out timeline as R410A? Good question.
It depends on what it's going into, right? So if we look
What
at
is it with us HVAC guys? Every answer starts with it depends, right?
if we look at the GWP of 134A, what you'll find is it doesn't fit in any of these categories because it is above 700 GWP. It will not be able to be utilized for any of these functions. So it depends on the equipment. And yes, 134A is being phased down. All HFCs are being phased down. So what are the appropriate replacements? It depends on the industry that it applies to.
It depends. Yeah. Anything over GWP of 700. So,
Yeah.
Here's a question. I don't know if we know this, but which from LinkedIn user name not showing, sorry, which subsector does bottled filler and drinking fountains fall under? Not
Got
sure.
me on that one. I'll have to follow
We'll
up
have
with
to
that
follow
one.
up with you guys on that one.
If you like reading 1,000-page documents for fun, I'll hook you up.
Yeah, exactly. Exactly. Yeah, you can get your mind twisted around. That's
Yeah.
and Adam Roeder asked that question. Thank you, Adam. Yeah. So another question, Silvano asked, "Do you see any potential impact of ERF systems with these changes?" And I would say yes.
Yeah.
Most of them are like, "Here's what we think we're going to do," but they're not 100% sure, so they're a little bit hesitant to publish things because there really are a lot of questions out there. But the basic principle behind it is we're going to have leak detectors at certain places, either at the HR recovery boxes, at the indoor unit itself, or in the actual zone sensor, or maybe all three. I don't know. And that goes for any HVAC equipment. It's going to probably have some sort of leak detection in it, which for me as an engineer, like I like to simplify things and keep it simple. There's already enough going on. I just can't believe we're
Sure.
going to have to deal with refrigerant monitors now, which are,
Well, maybe. Are we
yeah.
gonna have to deal
Fill
with
me in. Give me the expert opinion on this because I'm just
Absolutely.
a hack at this
I can
stuff.
tell you what I have seen. So I spent a lot of time with Johnson Controls at AHR looking at the VRF products to see what we're going to be doing for both refrigerants as well as mitigation. So with refrigerants, we are definitely making our transitions, and quite a few of our manufacturers are going to be way ahead of the schedule. So we're actually going to be seeing some of our R32 and 454B VRF systems coming out later in this year, possibly. But they were saying definitely by first of next year. So we're going to be seeing them very quickly. And we're going to be adding on our VRF products, we're going to be adding our refrigerant leak detection sensor at the indoor unit. But if you think about it, if I already have a communicating signal between our indoor unit and our outdoor unit, branch boxes, we're all daisy chained, what do I need for an extra input? Just another input. And so that's all we're actually going to do. We're going to be adding that refrigerant leak detection sensor at the indoor units. And if it is a branch box, we're probably going to see them in as well. And then our RDS, our refrigerant detection control, is going to be built into the outdoor units. Remember, it's just another input. It's measuring the concentration of refrigerant. And then if it gets into a heavy enough concentration of refrigerant, it's going to go into a state of mitigation. And that's another topic we can talk about if we ever needed to.
Got it. You
Yeah,
made
we
me
will.
feel better. I'm gonna sleep better tonight.
Oh,
One
absolutely.
other.
Yeah. It's not an add-on, it's added in. How about that?
Oh, nice. Okay, I have to remember that one. That's good. Okay, let's see. We got a couple more questions here. Jeff Saviano, when converting R410A to R32 or 454B, R454B, do we need to change the oil or TXV? There's many. I know, or
I
this is like heaven sent for us because there's so many layers and things we could do with this. And,
Yes.
I'm gonna let you go. I'm gonna let me shut up and let you talk about this one.
Ooh, so my answer would be none of the above, because we will not be converting R410A systems to any of these A2L systems. Because remember, If my system was engineered for an A1 refrigerant, I cannot replace the A1 refrigerant with an A2, A2L, or A3 refrigerant. It was not designed for it. And now if I was to do this procedure, I would now accept all liability for this new unregistered, uncertified piece of equipment. I hold 100% liability
Mm.
because there is no replacement for R410A. Currently, there's no SNAP approved EPA replacement for R410A. Our only service gas for R410A is R410A. So 32 and 454B will be coming out in brand new equipment that has been tested and certified. And if it falls into the M2 classification or M3 classification, it's going to have refrigerant detection sensors built into the equipment. So yes, you will not be using 32 or 454B in R410A systems, only R410A.
Yep. Thank you for that answer. And the oil, I learned live on LinkedIn when Don Gillis hinted at me maybe being incorrect. Was that one of them uses the same POE of 32 and one of them, I think 454B has the same oil as 410A. Correct me if I'm wrong. And then 32 has a different oil. Does that sound right? Or
I have not verified that, but I would not be a bit
okay,
surprised to see R32 going to PVE oil instead of POE. But I've not
got it.
verified that because I've not actually seen the physical equipment yet.
The
But it is
jury's out.
potential.
The
Yeah.
jury's out. Gotcha.
Well, it just makes sense that, one of the primary manufacturers of R32 is Daikin, and they use PVE oil in a lot of equipment. So I could see 32 being a PVE product, but I'm not 100% on that one yet. We'll see once we
Makes
get more
sense.
equipment coming to the industry what that looks like.
Makes sense. Okay, we got a couple more questions. By the way, these questions are great. Thank you all for watching.
Yeah,
Please
absolutely.
drop them in the chat. It makes our job a lot easier and a lot more fun. So please keep the questions coming. So we do have some more. Great. Okay,
Yeah.
so Patrick Tremont, PE, asks, how do R32 and 454B compare with regards to efficiency and capacity? And then I'll save the second part of that after my expert answers that. So efficiency and capacity comparison.
So I personally have not seen data on the performance of them. I have listened to people discussing that both 32 and 454 are a more efficient refrigerant, and then we have less total refrigerant capacity in the system. But I've not done a comparison model to model to see that specifically. So unfortunately, I can't answer that one, except for I have heard
Mhm.
that both of them have a higher efficiency rating.
Yeah, the data I've seen from the manufacturers is that negligible difference,
Yeah.
but slightly higher. So same information I've seen. So that's a great question, and I just think it's so close. It's not even like even if you're an engine, even if you're making equipment and you're deciding between the two, they're so close that you don't even take that into account, is what I was told for a couple of my manufacturers. So
Yeah.
the next part of that question is, will they both require a similar volume of, okay, I think we answered that. So we think so, yes.
Mhm.
So Patrick Tremont, thank you for the question. Matt Trotter has another question. Can you clarify how much space is required to store A2O refrigerants, like 100 pounds, question mark? Space
Oh.
requirements any different than what we dealing with today, or
Well, so then we get into storage. Now, I focus primarily on refrigerant capacity in our vehicles, and we also do training on what that looks like. 'Cause I didn't see another question about what about getting trained on this. So we have an entire training program specific for that, and we go over what does that look like. Because once we start storing larger capacities, we have to look at our storage facility and decide what classification it falls in. And in some cases, even requires sprinklers in storage facilities, but it's all based on volume. So that one I'm not prepared to dive deep enough into, but I'd be happy to follow up with you if you want to get with me later on that one.
absolutely, yeah. And so, speaking of training, we got another comment here. Russell Johnson, anyone wants to get certified A2L, please take the class. I'm a big believer in training, and if you're watching this in the future on our podcast or our YouTube channel, I'll have Clifton's information in the show notes. So check that out. Clifton works for ESCO. That's what they do. They go around and do training. So if you need training, you can contact Clifton at any time. So okay, so where can I find the table? Okay, so Joshua Robinson, where can I find the table with R410A and transition dates? You can go to Insight Partners website. We have a one sheet there that has the transition dates, a little bit about what A2L means. It's under the forms section. So, I believe that's correct. But anyway, if you go to our website, insightUSA.com. Again, if you're watching this in the future, listen, I'll put it in the show notes. You can go download the tab there. Okay, Thomas McCann. Can you use existing R410A refrigerant lines when installing a new R32, R4B split system? That's a great question. I don't know that I've heard that one before. I'm curious to hear the answer. So
That is a very good question. So I have set in on training where we've discussed that and the utilization of properly cleaning and flushing line sets. And I have yet to see an installation manual that says that you cannot. So I will leave it at that for now, because remember, our codes for the applications of them are not exactly specific on the inside of the line set itself. It's more of the installation of the equipment. But when you read the installation manuals for the equipment, I have not seen anything yet that says that you cannot utilize a properly flushed line set. But if that changes, I'll definitely be out there ringing that bell.
you'll let us know for sure.
Absolutely.
Awesome. Okay, another question from Travis Gray, PE. And again, if you have questions, please drop them in the chat. We're glad to answer them. So can existing refrigerant monitors in chiller rooms be used with these new refrigerants with utilizing new sensors, or is it product dependent? So that's a good question too.
That's interesting. I actually just had that conversation today with a manufacturer of RDS sensors for rack rooms. So that's a very timely question. So what we're seeing is that it really depends on the sensor that is being utilized for the application and the threshold limits that are programmed for it. So you're definitely going to have that conversation with the manufacturer of your controller to see if the controller will accept a new A2L sensor and then program the thresholds for the alarms. So it is a very big topic right now in the manufacturing side of RDS equipment and sensors, as what sensors are compatible, what systems need to be updated. So I'm not very fluent on that, but I can tell you that the manufacturers are absolutely looking at what systems can be simply utilized with a new sensor and a programmable threshold.
Excellent. I'm glad you're here to answer that one because I had no idea. But...
No, it's just
Okay, let's talk about the A2L aspect of this thing, because that has got a lot of people confused or concerned, or I don't know what the word is. Probably more confused than concerned. But
yeah.
So A2L. Let me get this. Trying to move these screens on. Okay, so ASHRAE 34 designates the safety classification of refrigerants based on toxicity and flammability. So if you look at this chart here, on the bottom, you'll see we have from left to right, lower toxicity to higher toxicity. And on the x-axis, on the y-axis, we have increasing flammability, which goes from no flame propagation up to higher flammability. And there's in between there's something called lower flammability and flammable. And I keep calling A1s non-flammable, and I keep getting corrected. That's not technically what it is. It's no flame propagation. And I'm like, okay. All right. So I try to get my terms right. Doing a lot of these live shows will get you accurate when you're talking to a bunch of engineers, especially. So this is kind of this chart you're looking at here with these boxes is right out of the ASHRAE 34. So, A1 is R410A is A1, lower toxicity, no flame propagation. And I understand there used to be just flammable and higher flammability, but A2Ls came out and they're not quite flammable and they're not quite no flame propagation. So they came up with a new classification called A2L.
Correct.
A, lower toxicity, 2L has to do with the flammability, right? So the first letter A means lower toxicity, B means higher toxicity. And, give us some, what would be like where's ammonia in there? Is B2 or B3? You said B something.
It's a B2 or B2L because it is both toxic and slightly flammable, but I don't know for sure exactly which one that falls. And I never actually worked with ammonia, but I should know that better. That's on me.
No. Something along those lines. It's the only toxic. Yeah. It's the only toxic example I could think of. That's the only reason I brought it up. But, 410A is an A1. But the two refrigerants we're talking about now, R32 and 454B, are A2Ls. So when you hear A2Ls, that's what they're talking about. Like for the longest time, I was like, what does this mean, A2L? I've never even heard that before. And I'll show a few slides here with illustrate that. So like, when you look at, if you look at this test chamber here in this diagram, this flask or this, I don't know technically what the word is for it, but basically there's a stopper on top. They put some refrigerant in there and they stir it up real good and they ignite it. And the spread of that flame is part of what determines you correct me if I'm wrong, determines the classification of it. So if you look at this picture and these yellow lines, you can see the flames barely touching it. That's R410A with no oil. And in my mind, an A2L is like a big burst of flame. But if you actually look at the test and compare it, it's actually very small. So you can see there's not much of a difference between the two. Ammonia is a B2L. Thank you, Todd.
Yeah,
He clarified us on it. So not much of a difference in terms of, the testing. If you compare that with propane, which is an A3, there's obviously a huge difference there. And if you look at all three of them, it's not, the A2L is not that big of a difference in terms of the flame spread. And I share this, but I don't mean to minimize like the responsibility aspect like we were talking about earlier. Like you still can't just top off a R410A machine with it. It's very serious. If you try to change out the refrigerant, you really put yourself in a big liability situation.
Absolutely.
The warranty's going to be voided. The UL's gone, so it's a very serious thing. But from the actual like flammability aspect of it, this is what we're dealing with. And I've got a great video, Clifton. Can I show this video?
You're welcome to.
For the flame test?
Spread all over the place. And it was kind of fun just showing the difference of those. Yeah, I'm a technician. Give me something to burn. I'll show you what something looks like.
All right, I got this video here. I'm going to show this guy. This YouTube guy I keep seeing. I'm going to let you walk through the video so we don't, since
okay.
you're here.
Sure.
If that's okay, I'll go
100%.
right to the flame test and you could tell us kind of what's going on. Let me see if I could cue this up here.
Yeah. So the goal was to be able to show what A1, A2, A2L, and A3 look like out in the industry. So I went with a non-regulated industry, which is the propellant industry that uses different refrigerants, different chemicals that we consider as classified refrigerants. So I actually have R134A, that's my A1. I have R152, which is my A2. I have 1234YF, which is the A2L, and then R2, well, propane, which is in that A3 classification, so that we can see what each of them look like, but with things that as technicians we might encounter in the field. So I've got a silicon carbide igniter, a silicon nitride igniter, and a Honeywell direct spark ignition module, so that we can see what those look like, since we know that they're all actually flammable with different ranges of flammability.
Yep. Let me get that back up here. I was having
Sure,
trouble with it.
absolutely. So I'll use these in a couple different ways. I will use the refrigerant in vapor state going across the different ignition sources, and then I'll use it in liquid state. And so what we'll actually end up seeing is that our A2L, or especially our 1234YF, I actually don't get any ignition to it in the vapor state. But when I'm changing state from liquid to vapor, that's actually when I have a little potential for ignition. And so that's where we need to be most careful, is when we're going
Gotcha.
into a vapor.
Let's see if I can get this back up here. So, okay, so let me go back here because I missed the first part of that. And when we're live streaming, just so you all know in the audience, sometimes these things don't work, and it looks like that might go down that road right now, but we're going to try and play it anyway.
We can at least explain and give reference. If you want to see it later, you can actually just get an idea of what does flammability look like outside of the test chamber. Test chamber is awesome to be able to see that, what does propagation means. Put a V in there, we put refrigerant, put ignition. If we touch it, it's going to be an A2 or A2L. If our flame comes around and touches itself, then we're going to give it an A3, a highly flammable gas. But our A1 does actually light. It just has to be in the right condition. And our A2L is actually very, very similar to an A1, but it has definitely more flammability to it once we're changing state.
Well, we're getting a little bit of movement here. Let's see if we get this video going. Okay, so why don't you tell us what's happening here? So we've got some...
Yeah, so this one is going to be the 152. This is our A2. We don't use the 152 very often in the industry. We use it. We actually had looked at using it as a replacement for R12 before we went to 134A, but it is out there in applications.
Okay, so we're not getting it's not screen sharing for some reason, but
Sure.
we'll put a link to that. Like if you're watching this again in the future, we'll put a link to that. It's a really good test to show, like when I see propane getting lit, it's a big, I've had
Yeah.
one of these propane torch things before. We used to use it to kill the weeds and stuff like that. And this is not, when you see it trying to be lit, it's very difficult to light it at all, or to keep it lit is almost impossible. But anyway, so we'll share that. We'll share that at another time. Okay, so a couple more questions here. And thank you again for the questions. And Clifton, thank you for joining us on a short notice. So Clifton had nothing 2 hours ago. He thought he was going to be, hanging out, having a beer or watching TV or something. I'm like, hey, what are you doing at 4:00? So thank you for coming on. We appreciate it. And 10,
I love this.
yeah, and 10 o'clock tomorrow on LinkedIn Live, we'll have Don Gillis on here, so you can check that out as well. Okay, so here's some great new questions. Namir asks, what options do you have if existing R410A VRF unit needs replacement after 2025? I'm not sure if that means needs more refrigerant or needs new equipment.
Well, yeah, let's look at that from two different aspects. So let's look at that from the refrigerant itself. So the importance of reclamation and bringing refrigerant back in to be properly reclaimed and put back into service gas is that, remember, those restrictions on those GWPs were based on newly manufactured refrigerant. The more refrigerant we bring back from the industry as reclaimed gas that's reprocessed back into AHRI standards, that is service gas going forward that is not calculated into that original GWP calculation. That was only for newly manufactured refrigerant. So it's crucial that we continue and that we increase and escalate the reclamation of refrigerant, and we repair leaks when possible so that we have a longer period of service gas of R410A, because there isn't, like I said earlier, there's no EPA SNAP approved replacement for R410 right now. So it's important to get that back. Now, equipment wise, now we're getting into, if I have an existing R410A system, I have my theory on this, but I have to be very careful with this on a multi-port ductless or VRV system. Think about it. What is the difference between an R410A indoor head and, say, an R32 or an R454 indoor head, if they operate under the same pressures or similar pressures?
I would say not much other than the sensors in the equipment.
Exactly. So going forward, I anticipate that being a solution, is that we will still have replacement indoor components. They just may be equipped with a refrigerant detection sensor. I've already seen residential furnaces hit the market. I had a call just a couple of weeks ago from a technical service advisor. He said, hey, I know you're up to date with what's happening with mitigation in residential. I have a furnace that has an error code on it that I don't know what it is. I said, what's that? He says, refrigerant leak detection sensor not located. I went, oh, well, that's interesting. That just tells me that the furnace wants to know, is it connected to an A1 system or an A2L system? That's all it really wanted to know. Is there a leak detection sensor that should be getting plugged into me? So if I have say we no longer manufacture R410A indoor pieces of equipment, but we have replacement A2L that has the refrigerant leak detection sensor that is not needed on an A1 system, we still have replacement service parts. So I hope that that's the way the industry looks at that and the manufacturers look at that. I anticipate seeing that, but that is definitely not in stone for replacement parts that I have seen from any manufacturer just yet. It's an assumption on my part right now.
Yeah, I think that's a fair assumption too. So. Okay, thank you, Namir. So Travis Gray is asking, this may be a comment based on a previous question. It is also a big deal of replacing chillers with A2L in the same room as an open flame boiler or water heater. You need to shut down the boiler if there's refrigerant leaks. So I think that would be probably true. Travis is, I don't know that part of it, so I'm hoping. It sounds like that would be right to me.
Yeah.
Yeah, more to follow on that. We're really actually waiting for a little bit more information to see what the effects are going to be. So thank you, Travis, for the comments. Thomas McCann says, I keep seeing some videos on R32 systems exploding by something called a diesel effect. I'm not sure what that is. Some of these videos are really scary. Any comments on that, Clifton? I mean, I've seen tons of videos where it's extremely hard to light these refrigerants. So
Yeah. I absolutely do. So I can now. I would want to have a little bit more information to verify an R32 system with a dieseling effect. I can tell you what I have witnessed and validated, that some of the ductless videos that we have seen from other countries that have explosions of ductless systems are because there are places in the world that have allowed R290 ductless systems to be introduced into the market. So I can absolutely imagine an improper installation and an improper servicing of a R290 ductless system, which are not allowed in the United States, that have not fit any kind of building codes, could absolutely have some explosive characteristics. So if I found some contradictory information of that, I would love to see it. But all the videos that I have been shown and witnessed myself are R290 ductless systems that we'll probably never see in the US anyhow.
And R290 is propane.
Highly flammable.
Is that right? Okay.
Yeah.
You may have said that. I was looking at the next question here, but I thought so. That's propane, and I would say too, and I do a lot of stuff online, and there's a lot of people who will do stuff to get views that may not be 100% accurate. So please double check everything you see out there, especially if it's some kind of scary thing they're trying to get views on. So just my 2 cents input there. So Alex says, just out of curiosity, why haven't R744, which I think is CO2,
CO2, absolutely,
become more streamlined? I get this. This happens all the time. I'm giving this presentation. Actually, I'm speaking tomorrow online at the ASHRAE Manitoba chapter. So I'm super excited about that. It's my first. It's my first international talk. So now I could say international speaker Tony Mormino. Like I can introduce myself that way for my one international talk. So I'm super excited about that. So shout out to ASHRAE Manitoba for inviting me up there. I appreciate it. So a lot of times we do this presentation at the end. Why don't we go to propane? Why don't we go to CO2? And really, there's no. And I'll let you talk about it more. But it's extremely high pressure, and I believe it has. Is it CO2 that has a problem with copper, or is that one of the other refrigerants? I don't remember. I'll let you talk about your experience with that.
I'm actually not a CO2 guy. I wish I would. I've got to learn more about it. We're actually working on a CO2 project that I'm not involved with, that I'm looking forward to our CO2 training so I can learn a little bit more about myself. I always have to reach out and learn more about CO2. I've never worked on a CO2 system personally.
Yeah, I am not a CO2 guy either. I do have this slide here, which I'll try and share. So the CO2 there, very high pressure, 1,000 PSI. That's high. So a standard R410A is in the 4s.
I hit aluminum coils.
Yeah. Requires stainless steel refrigerant in coil tubing, very expensive, and welding instead of braiding. So it's not very practical. Not very feasible for commercial package units. Now I can tell you it is very efficient for heating, and we do actually have a specific manufacturer that's making a CO2 heat pump, air-cooled heat pump chiller. So you can use it for applications like that if it's and then we talked about ammonia, which is toxic, and mildly flammable. And then, you got to evacuate if there's a leak. And it's also corrosive to copper. So I think packaged rooftop units and chillers have copper in them. So just a little bit. So that wouldn't work. And then the propane, I don't know. I just can't even imagine. I wouldn't have a big problem with it if it was tested, but a lot of people might have a problem with that from the flammability standpoint. So,
absolutely.
Okay. So that was a great question by Alex. Okay. We got a few minutes left here. Reference above to open flame boilers. Oh yeah, ASHRAE 15.
Travis, yes.
Great, thank you, Travis. 8.13.1. I'm looking for an expert on ASHRAE 15 to come in and have this conversation. So I'll find one and we'll bring it to you guys soon enough. But anything else you want to cover? We burned up an hour here, which is great. And thank you all for joining us. What else? Any parting words on this, Clifton? Oh, if you need training, and I think I mentioned this before, please reach out to Clifton and their group over there at ESCO. They do a fantastic job. A2L training, among other trainings. Again, check out the show notes, and you could find Clifton's contact information, their website, and anything else there, Clifton, you want to talk about before we go?
That's it. I really appreciate you plugging us for the resources. We look forward to, joining forces to educate a community. I mean, we're all part of this community and we all have these challenges. And so as we go forward, these relationships are going to be key. I already see some other industry professionals that do the same kind of, education and speaking out in the industry that's even joining us today. And this is really what it comes down to. We all have our part to become better together.
Excellent. Great parting words. Thank you, Clifton, for the short notice. And we'll hang out here for a minute. I'll put up some QR codes for our guests if you want to connect with us on the HVAC, on our YouTube channel, HVAC TV, or our podcast called the Engineers HVAC Podcast. And thank you so much for joining us. Thank you, Clifton.
Thank you. Appreciate it, everybody.
Thank you.